question 9C from page 48 in the review. It's sense elimination. We're going to solve it using graphing just so we can review our graphing skills. Okay? So they give us two linear equations. 2x plus 5y equals 3. 2x minus y equals negative 3. In order to graph, remember I wanted you guys to get used to slope y-intercept form. So that means I have to set both equations equal to y. Okay? So, just like when we're doing substitution, we're setting an equation equal to a variable, except when we're graphing, we're specifically focusing on y. So, in the first equation, that means eventually I want it to equal just y. And in this equation, eventually I want it to equal just y. So we're going to be rearranging them. Start with the first equation. Actually, no. We'll start with the second because it's a little easier. Then we'll go to the first. So, we have y on this side. I'm going to move 2x to the other side. Negative 3 minus 2x. Then when I bring the negative over, it becomes y equals 3 plus 2x. So, slope y-intercept form, always remember y equals mx plus b. M is our slope, b is our y-intercept. When I look at this one here, my slope is the number attached to the x. So my slope is going to be 2 over 1, because it's a whole number. My y-intercept will be positive 3. So I've rearranged that equation, set it equal to y. Our first equation, I'm going to set this one equal to y. First of all, we're going to move the 2x again to the other side. So this becomes 5y equals 3 minus 2x. Only difference this time is I have a coefficient in front of the y, the number 5. I need to move it. It needs to be just equal to y. So I'm going to have to divide every number by 5. What that means, y will equal 3 over 5 minus 2 over 5x. Technically, I'm done. I have a slope. My slope is negative 2 over 5. We keep it in fraction form so we know that we're going to be going down 2 and to the right 5, or we're going to be going up 2 and to the left 5 because it's a negative slope. Our y-intercept is 3 over 5. So if it's hard to tell in fraction form, divide that. Turn the y-intercept into a decimal so we know where to put it on a graph. So we're going to go down to our graph. We have our two equations in slope y-intercept form. Here's one of them. Here's the other. They're both set equal to y. In order to put it in slope y-intercept form, we always have to have it equal to y. Okay, now that we've fixed the graphs and the numbers, let's deal with our second equation. Once again, it's the easier of the two to graph to start. So our y-intercept, and I'll put our numbers up here.
It's going to be magic. It's going to be magic.
So we have our numbers. Once again, the y-intercept is positive 3. So, positive 3.
Come on, buddy.
I go on my y-axis. I go up to positive 3. I know that the line is going to intersect the y-axis right there. So that's one of the points on the line. From that point, I'm going to graph the rest of the line using the slope. The slope of this is positive 2 for the rise and positive 1 for the run. So, we'll do this one in green. That means we're going to go up 2 over 1. So here's another point on the line. From that point, we can go once again up 2 over 1. There's another point on the line. I have 3 points on this line. Let's continue this. So, I'm going to graph this. Our line can be something like that. Okay? And now we could continue it actually all the way down. connect them, draw a straight linear equation. Then our straight line. Second equation. This one's a little more difficult. 3/5. I can find out what that is as a decimal. Anyone know what that is as a decimal?
Find what is decimal?
3/5 is a decimal.
0.6?
3/5 as a decimal is 0.6. Okay? So what that means is from the origin, my y-intercept is going to be positive 0.6. So we don't have an exact spot here, but we're going to make an estimate. It's a little over halfway. So it's probably somewhere there. So it's a little more difficult to graph. Okay? From that point, I need to move down 2 and to the right 5. So when I go down 2, I'm still going to be on that roughly 0.6. I have to move a full unit down. So a full unit down would be, the here, that's 1, 2. I've now gone down 2. So I'm not on actual grid corners right now. Okay? But I'm still only moving 2 spaces from that y, the point of y intersection. I gotta move 5 to the right. 1, 2, 3, 4, 5. So my point is roughly there.
So you bring 3 down and go across 5.
I bring, so the same idea with our slope is from that y-intercept, we can go up 2, so 1, 2, somewhere around there, and to the left 5. Okay? I can apply the negative to either the top number in the slope or the bottom number. It doesn't matter. We'll still be on the same line. So you go 1, 2, 3, 4, 5. So there's my other point. So now I can draw a line. I got 3 lines to work, or 3 points to work at. Start here. Let's go through our 3 lines. 3 starting points. Looks like that's about it. So we have our lines. We have a point of intersection. So the point of intersection is where these 2 lines cross, right here. That coordinate is -1 and 1. Or x was -1 or y was 1. That's the point of intersection. So whether we use substitution, elimination, or graphing, we still would end up with the same point of intersection. Only difference with graphing is sometimes it can be difficult to tell where the 2 lines are passing. So I want you to be, if you're graphing it, be as precise as possible. Okay? Most likely it's going to be whole numbers on the test that I'm going to give you, the points of intersection.
It's gonna be what?
Whole numbers.
Oh, okay.
Okay?
That's a good thing.
Okay. So that was our graphing. Set them equal to y. Find our y-intercept, and then apply the slopes. Question 12b, page 49.